Recently, I did a POC for a customer and I thought I wanted to share some of my experience and thoughts for a broader audience. All of this is strictly my own opinion and shouldn't be accounted for best practice, but more for inspiration. I think it's important to share that several constraints and success criteria were put in this POC, which is also reflected in this demo implementation. In this demo, we will explore a possible take on how to make a data warehouse using Azure Data Factory, also known as Synapse pipelines, to create ELT or ETL flows that spans from ingesting source tables from a source system to populating facts and dimensions in a SQL database. I will summarize the architecture behind this demo, and what it shows is we are using Data Factory to extract data from the source system and landing the incremental changes to a staging table. Afterwards, we merge the content into an extract table that is now one-to-one with the original source. Rows that have been deleted at the source side are soft deleted at the extract table, meaning we will leave columns to indicate if a row has been deleted. This will be later needed in the flow as we intend to implement type 2 dimensions. Before we let the developers build on our newly sourced data, it was a requirement to clean and prep the data. For instance, some columns required trimming white spaces, while all dates were formatted as whole numbers that they wanted to convert into regular date formatted columns. In this demo, this is simply implemented as views in SQL, but could also be materialized as tables if desired so. I choose to implement the view approach because I could easily script out the views using Excel. The last step in this architecture is centralized around facts and dimensions. Those have been built case by case as the nature of these varies a lot. Data extraction from source systems, on the other hand, is very generic, and the pipeline for this activity has been designed to accommodate a universal range of data sources. To achieve this, I have made two tables that contains metadata about the source tables we are ingesting and another table to control the incremental load we are doing in the data warehouse. A set of stored procedures have also been made to interact with those tables. Take for instance a procedure to retrieve information of when a data flow was last updated or what the primary key are for a specific table. So let's head over to my laptop and see how I implemented this. Let's start at the extraction layer. This is my master pipeline for the extract layer. The first thing I do is I send a query to the metadata table that will give me a list of tables to ingest from and other useful metadata about last pipeline execution. These information are passed into the nested pipeline that are executed for each of the tables. In here you will see all the columns from the metadata that is passed as a parameter. You'll see here it's called this pipeline. So this is a generic pipeline I made for data extraction. What it does is it starts by looking for metadata about the table we are going to ingest. Then it will copy all the primary keys from that specific table and load it into a blob in our data lake. Then we will start by copying all changes since last load using the copy activity and put it inside a staging table. And then we will merge all the data from the staging table into the extract table and update our metadata afterwards. The reason for this design and not doing everything in a data flow is because the original source for this POC was an on-premise SQL database. Dataflow has this constraint on integration runtime that you basically need to land it somewhere in the cloud before you can work with it in the data flows. There are good reasons to this, but let's talk about this in another session. If we deep dive into the data flow, the data pipeline will upsert everything from the staging table and put it into the extract table. But more interestingly is this part of the data flow where we compare the primary keys between the extract table and the source table to flag which rows needs to be soft deleted in our extract table. So you will see here we update the source delete flag and last updated column if the primary key doesn't exist at the source side. So once all the new data has been ingested, we have a one-to-one copy of the data in our data warehouse. We automatically also have cleansed the version of it because of the transformation we defined. Data analysts and data engineers can now explore this data and think about how to implement the requested facts and dimensions. In this demo, I've implemented two different dimensions in two different ways. The design principle of the two pipelines are almost identical. I start by getting some metadata about the dimension, and then I get some information about the incremental load status. Then I run my transformation rules in this data flow that is unique to my dimension and load it into a staging table. Afterwards, I call a generic pipeline or data flow that merges the content of the staging table into a dimension table, which also contains the logic around how to build a type 2 history. This logic is quite similar to that of the extraction layer, where we use the combination of non-key columns and key columns to determine the status of the row. If you're interested in this data flow, make sure to explore the template gallery, where you will see a lot of different examples of how to implement data flows that can accelerate your journey. For my other dimension, you will see a more stripped down version of the previous pipeline. I've hard-coded the parameters instead of retrieving it from a metadata table, and in my staging data flow, I'm using a stored procedure to do all my transformations before syncing it into the staging table. Be aware that using this approach, you will be using the SQL database to do the transformation and not the Spark engine behind data flows. You thus need to consider if your database can scale to accommodate for this power needed by the transformation. To finalize this demo, I've also provided a sample of a fact. This pipeline is rather simple, as it doesn't utilize any metadata and full loads the whole table every time. Same as the dimensions, I'm using a data flow that applies the transformation rule unique to that flag before syncing it into the staging table. Afterwards, I run it through a generic data flow, and in this case, it adds a few metadata columns when a row is inserted to the fact. And that wraps up today's video. I hope this was helpful, and I see you on the next one.